Good afternoon, everybody. It is 4:15 Eastern, so we're going to go ahead and get started. My name is Blake Blaze. I'm the jack of all trades here at DataClassroom, and I'll be playing the role of MC for the webinar. So if you have any questions, feel free to throw those in the chat, and I'll try to keep those moving as our two presenters run our webinar today. And first, I'd like to introduce Dr. Paul Strode, whom you may know from his blog, Mr. Dr. Science Teacher, or one of his many contributions to the field of science education, or maybe even from his appearance on NPR's All Things Considered. Paul is an award-winning science teacher who has taught a variety of science courses at both the high school and university level, and currently teaches biology, anatomy, and physiology and science research at Fairview High School in Boulder, Colorado. Also joining us is Dr. Reedy, co-founder and education director for DataClassroom. Aaron began his teaching career in Chicago public schools, where he taught primarily biology, but also taught some other science courses before leaving the classroom to pursue a PhD in evolutionary biology at the University of Virginia. And with that, I'd like to turn it over to Aaron.
Thanks, Blake. Thanks for the kind introductions there. Very excited to be doing this today with Paul. I want to just start out by kind of telling the story of how I got to meet Paul. And it was really when I was at the beginning of developing DataClassroom. It was pretty early on, and we were attending the National Association of Biology Teachers Conference, NABT, in Chicago. And I only knew Paul through reputation. I'd known him through some of the work that he had done with our friends at Data Nuggets. And I said, I gotta meet this guy at NABT. I was a little bit nervous because I thought to myself, if he isn't interested in what we're building, then nobody is, and this is going to be the end of the dream for DataClassroom. So I introduced myself to Paul and got him to come out to lunch and showed him DataClassroom, and I was pleasantly surprised that he's been using DataClassroom in his classroom almost since that moment, and he has given us so many good ideas along the way as we've continued to build DataClassroom, and very grateful to have met Paul, and glad that we're still able to keep in touch, and even more glad to finally have him come and co-host a webinar with us. So thanks for being here today, Paul. All right. I want to go over just a little bit of what the plan is for today, and in just a minute I'm gonna turn it over to Paul, and Paul's going to show you different ways that he has introduced DataClassroom to his students, and he's going to show you ways he's introduced it in two different courses, one with a younger group of students and one with a slightly more advanced group of students. And he's got some great data sets that are easy to collect in the classroom, one on height versus wingspan, and one on exercise and heart rate. And then I want to give Paul plenty of time to show you those. I want to ask him some questions, and Blake will have questions as well, but questions about what ways that he's been able to incorporate DataClassroom and different techniques that he's used to introduce his students to the statistical concepts, as well as just using the DataClassroom tool. And then I want to show you a new data set for DataClassroom that is not in the Ready to Teach library yet, but it will be soon, and it's on the relationship between healthcare expenditure and child mortality. It is the last data set from this Big Problems webinar series that we've been doing, encouraging people to work with real world issues when they're working with data and things. We've talked about vaccines in the past, we've talked about extinction events, we've talked about global warming, and this data set touches on global poverty and global healthcare, and so we'll end by showing that. So with that, I think I'm going to turn it over to Paul, and you're going to start with the height and the wingspan data set?
Yes, I am.
Okay.
Let me just give everyone a little bit more of a background. Funny that you discovered that 2005 NPR reference. That's pretty funny. So when I was in an undergrad in college, the only memory I have of data analysis, well, I have no memory of it from high school. The only memory from college is when I did an independent study as a senior. I analyzed the water quality of our local river, both above and below an old dam, and I remember only going as far as like standard deviation, perhaps, with the data. And so when I got into teaching high school, from 91 to 99, I didn't have my students do much with data at all, because I didn't know much about data myself. I did a master's in science education at the University of Washington during those 8 years, and I took my first statistics class. It was a class called Basic Educational Statistics, and it was really all about analyzing student assessment data. And so it wasn't, I didn't see it applicable to any data that we would be generating in my science classes. So it wasn't until graduate school, with massive data sets that I was gathering from bird migration and bud break data from the trees in my research, that I had to figure out how to analyze them. And I didn't have time to take a stats class, so I spent a lot of time in the stats department, actually getting help with my data, learning about ANOVA and t-tests and just all kinds of things. And so when I went back to high school teaching out here in Colorado, I realized that it's really just math, and there's adding, subtracting, squaring, dividing, and so if I could start with just the simple math with my students, and teach them how to generate descriptive statistics from raw data, maybe they could start wrapping their heads around inferential statistics, and maybe by having them go through those steps of calculating the squared difference between a measurement and the mean of a data set, et cetera, that they would see what's behind the curtain of statistics. And so that's how I started teaching statistics when I came back to high school teaching. And I slowly developed some materials for my students. And then Aaron, actually, you got in touch with me to take a look at some early versions of DataClassroom, I think before it was even publicly available. And I had a couple of students, work through a little bit, give me some feedback, and then we tested in my classroom, and by then there were other teachers doing it. And so I learned to really love it. My students love it. So that said, I'm going to share my screen, if that's okay, Aaron.
Yep, go for it.
All right. So I'm going to share it. It's going to look funny for a second here, I think. Oh, now I got to.
Just slide that down. If you grab that toolbar, you can probably just slide it to a different spot if you don't like it there.
Trying to slide it, not sliding.
Zoom window is always where you want to click.
Exactly. Let's see. How can I?
Well, at least it's smaller now.
Yeah, let me get to, here's what I want to get to. So you should see a Google Doc called Unit 1 Skeletal System. Is that what you see?
Yep, that's what we see.
All right, so here, this is my anatomy and physiology class. This is Unit 1, the skeletal system. We started school August 19th, and so now we're about a week and a half into the semester, and so the students have done a lot of work on the human skeleton. They're really starting to learn the bones, and so this is when I introduced them to data, and a lot of them really haven't done much with data in this class. These are our sophomores, juniors, and seniors, and most of them are our non-advanced students. And so I have these 3 focus questions on this day. What is the relationship, if any, between the human body dimensions of height and wingspan? How similar or different are the human body dimensions of height and wingspan? And then number 3, how can we visualize a sample of height and wingspan data to help answer questions 1 and 2? And so I have them record their data on a Google spreadsheet. And so I have it linked here, and I'll show you an example of that spreadsheet from this past fall. And then of course I've got them a link to DataClassroom, and I've already uploaded all of their logins to DataClassroom, and I give them a screenshot here of what it will look like when they go to dataclassroom.com. The easiest way for if they're signed in through our if they're signed into their accounts or their district accounts, then they can just click on sign in with Google, and it's really simple. It takes them right to their DataClassroom site. And so here is, if I can get to this, I think it's this tab here. Yeah, so I have my students, we get out the meter sticks, and everyone measures their height, and then their wingspan, and they record their data here in the spreadsheet. Here's me, these are my students from this past fall.
And Paul, if I can just interrupt for a second,
yeah.
just point out that Blake has put a link to this sheet in the chat. So if people want to follow along, they'll be able to open this and do as you do here.
Right. So you'll have a view only version of this sheet. And if you want to mess around with it yourself, then go ahead and make a copy of it. But I have, if you notice that the tabs at the bottom, the first tab here says data sheet for regression, and the second tab says data sheet for t-test. And so this is how students would normally record data like these. They'd have a column of the subjects, a column for height, and a column for wingspan. And this is just fine. This is all set up for DataClassroom to be able to interpret these data for a regression analysis to create a scatter plot, an XY scatter plot. And so once we get all of our data recorded, I then, and I don't have this second sheet filled out yet when I'm showing this to them, but this is what it looks like when we're finished. What I do is I then show them what it looks like when you create a tidy data table where every column is a variable. And so here I've taken away the subject column, and now I just have a column titled body dimension. And I've got the height variable here. I've got, I have 23 of those. And then I've got all the wingspan data below that. And then the next variable is the measurement for those body dimensions. And so here are those measurements.
And Paul, so this is what you've just shown, a data set, and then you've shown something that fits very neatly in the parameters of tidy data, right? And
right.
How do you explain this to your students about, like, what are you doing when you reformat this? How do you explain that in a way that they grasp so that this makes sense to them?
Well, I tell them that we need to, if we're going to analyze, if we're going to compare two data sets for differences, then we need to make sure that we create categories for those two data sets. And so the body dimension variable has these two categories of height and wingspan. Mm-hmm. And I tell them this is how a lot of these data analysis apps can interpret data. They need to know what the variables are. Mm-hmm. And so I don't know if that's what you were.
Yeah, that's very much. I just wanted you to share that with people, because I know it's definitely one of the things when people begin working in a more professional grade data tool like R or Python or even DataClassroom, which is meant to be for kids, but it still works off of this format where each column is a variable in most cases, and there's sometimes a little bit of a learning curve as people are learning to reformat like that. So I was just interested in hearing your approach.
Yeah. Yeah, I do tell them that when they get into, if they take a course in college, or if they use something like R, that they'll need to be able to organize their data like this. And some of them might have, heard someone say, yeah, I have 6,000 lines of data. Well, this is what they're talking about. We have 46 lines of data. And so some data sets, go super deep with thousands of lines of data. Now, Aaron, how many lines of data can DataClassroom manage?
Well, it doesn't actually have a hard limit on that, and but it does have a practical limit. And I will say it depends. If you are doing, if you are just making frequency plots or histograms, you can have a data set with 10,000 rows, 15,000 rows, and it'll perform just fine. However, when you do a scatter plot, the practical upper limit right now, I would say, is about 2,000 or 2,500 data points, because the computer has to render each of those individually. And so it's just a very slow process, and it gets a little bit bogged down with data sets beyond that. We have a new product coming out called DataClassroom U, which is made for the university market in particular. And so as part of building that, we're doing some things on the back end to make DataClassroom run faster with large data sets. The benefits of that will apply to our regular DataClassroom as well. So short answer to the question is about 2,000 data rows of data right now, but that's soon going to be even greater.
Yeah, and 2,000 is absolutely plenty for high school purposes, for sure, in middle school.
That's my feeling as well.
Yeah. So at this point, as I'm presenting, as I'm working through this with my students, they have their laptops open. They're following along, looking at the spreadsheet as I'm managing the data, and I also have it projected on the screen. And so then the next step is I have them all open DataClassroom, and then I walk them through fetching a spreadsheet.
And Paul, so, before we move on, can you just go back to that data set again? Because there's an audience question. And this question comes from Kristen Hunter Thompson. Mm-hmm. And she's wondering why you dropped the student variable when you moved over to the tidy data organization.
And well, that is because we don't need to know, we don't need those identifications to analyze these two data sets for differences between means.
Mm-hmm. And I'll point out that he could have included it in there, but like he said, you just didn't need it for this purpose. But if you did, you could have had a column for student, and then you would just have their name would appear twice in the tidy data set, once for their height and once for their wingspan.
Right. And I don't even need it for this spreadsheet. It's just a way so that students they know which row is theirs, basically. All right. So then, so we've got these two tabs, and we go over here to DataClassroom. Now this is what the teacher dashboard looks like. The student dashboard is going to look, I think, Aaron, a little bit different from this. Is that right?
It almost looks the same. Really, the only difference is the classes will be just the classes that they're members of, instead of the classes that they, because they don't administer classes. That's the main difference.
Right.
But more or less, it'll look the same other than that.
All right. And so, I want to import a data set here, and I've got several choices. I can fetch from Google Drive, which is what I'm going to do. I haven't used these other options before, but maybe after I go through this, then Aaron, you can explain how to copy and paste. Sure. And so I'm gonna fetch from Google Drive. So I need a link to my spreadsheet. So I go back here to my spreadsheet, which is somewhere hiding here. There's my spreadsheet. So I'm just going to highlight the URL, copy it, and paste it in here and then fetch. And sometimes, and this is something that Aaron, I don't know if you can explain. Sometimes it asks me to log in again.
It just depends on when you've authenticated with Google and then when you've last logged into DataClassroom. Basically, if it has the credentials to go ahead, it won't ask you again. But if it's somehow been reset, it's going to ask you to do it again.
Yeah. So it's just one little click. So here's the title of my spreadsheet. And now you have two choices of which tab you want. And so the first comparison I wanted to do was to see if there was a relationship between height and wingspan. And so that's this first tab. So I'm going to say done. I want that tab. Okay. And so there are the data, just like they were in the Google spreadsheet. And it automatically interprets that first row as the variables: student, height, and wingspan. And then the next row and all the rows below are all the data. So over here under student, this is information. So I'm gonna call this data type info, and then both height and wingspan are numeric data. And now when I go and fetch the other tab, you'll see when I'll use categorical. All right, so now I have everything set, and I just have my students go right to graphing. So I click on the graph here, and since the student is info, then there's no reason to show it, and so it doesn't even give me the option to show that variable. But I want to show height, and I want to show wingspan. And the default here is a scatter plot, and so it just automatically defaults to the scatter plot. Now notice that here wingspan is on the x-axis and height is on the y, and I'm more interested in knowing if height can predict wingspan, not if wingspan can predict height. So I'm going to switch the variables over here. I'm just going to click on X for height, and it automatically flips the variables. So as I'm doing this with my students, again, this is on the screen in front of the classroom, and they're all following along. And I'm checking in with them, of course, as we're working, but they're all trying to create their own graph the way that I'm building this graph. And so I have to stop and check for understanding and make sure everybody's in the same place. So one of the first things I like to do is I like to change the appearance, and so the default are these larger circles that are colored light blue, and they're big circles because most of the data that like a middle school class and even some high school classes will be generating will be maybe 10 or 15 data points, and so you want nice, big, obvious data points, but I like to make these a little bit smaller, and I like to make them black. So I'm changing the appearance to black, and then I like, maybe 7, size 7. So now I've got my my data points all set as the way I want them to appear, and then down here further, you can pick your regression line color. And so instead of orange, I'm going to pick kind of a brick red color. All right, so now I close that. So now I want my regression line. So here's the relationship. Now at this point, I tell my students how to interpret the R-squared value, but we don't get lost in the weeds of what a regression analysis actually is. We don't talk about the R value and statistical significance. And so I tell them here, I said, with this R-squared value, this means that height predicts wingspan. A person's height predicts a person's wingspan with around 91% accuracy. And so that's pretty good. And so, yes, indeed, there is a statistic. Well, we don't know if it's statistically significant, but there's a pretty strong relationship between height and wingspan. And so once the students get their graph, they can copy it and then they can just paste it to a document. So I'll actually go here to that. I'm just going to show you what that will look like. Drop this down to 100%. So I'll just paste it here. So Control V, and there's the graph. And so so then they can now write up a summary of this relationship and what we did. So back to
Paul, you said something in there that really resonates with me about not getting lost in the weeds of all of the mechanics behind regression, because that's not the point of what you're teaching at that moment, right?
Exactly.
The relationship is more what you want to explore and how you can see the relationship visually. That's one of the things I think can be intimidating about statistics, is like there is a lot of background, but fortunately I don't think in every situation you have to get into it. And most of them, I think you're better off doing like you did and sort of not getting in the weeds with it.
Sure. Okay, so so now I want to create another data set in DataClassroom, and I want these data because now I want to compare the means between height and wingspan.
And Paul, while you get that data set in, can I take over the screen share and show people how to do the copy paste in?
Yes.
Okay. So let me grab the screen share for a second. And okay, so I've got the screen share now. And what I want to show you is a different way of bringing in data. Paul showed you the fetch from Google Sheet. Paul, this is the right data set that you want to bring in?
That's the one that, I was going to bring in next.
Okay, so and you can go ahead and do that, and then when you come back, it'll be up there. But all I did was copy the cells that I wanted, right? Including the column headers in row 1. And then when I go to DataClassroom, and I'm gonna go back to my dashboard, and I'm here, I go to the same place that Paul did when he was fetching this import data set from your own data, this green button down here on the bottom left. And I can go to, instead of fetch or upload or create, I'm gonna do the paste copied cells here. So I just put my cursor in this field and I Control V, I just paste it in. We'll call it, Paul's example. And you can see that it brought the data in just with that copy paste in. So it doesn't have one of the nice things about doing the fetch with Google is if you change that original, you can refresh it and bring in the most recent version. But if you know that you want to grab data from somewhere and copy paste it in really quickly, this is just a quick way to bring it in. So I'm gonna end my share and I'm gonna give it back to you, Paul.
Okay.
And by the way, if you are following along and you want to put Paul's data set in there at home, I recommend just do the copy paste it in, and you can have that data in, and then as Paul goes through it, you'll be able to follow along with what he's doing.
All right, now I got to remember how to make this smaller.
The Zoom button
problem. All right, so I'm going to go back and copy that URL again. Go to DataClassroom, fetch it. Let's see, I'm using.
You've just already got a file with that name.
So we'll do means comparison. So now I want this other tab. And I've got a question for you, Aaron, while we're looking at these two tabs. What if you've got 20 tabs on a spreadsheet and they extend off to the right of this window?
I don't know if I've ever tried it with 20, but you can get so many tabs that it extends off the window, and they'll be sort of floating in space off the window. And you can still click them. I don't know if I've ever tested it to where the point where it goes off the screen. And that's a good question, and I don't know the answer.
I'm just thinking of like students that are they're not that good at managing data on spreadsheets, and they've got all these tabs. And the best thing for them to do is just to create a new spreadsheet with just the tab they want.
Yeah, certainly it'll be functionable. 6 or 8 tabs would be no problem. I don't know if I've tried it beyond that.
Yeah. All right. So now I have my second tab, and so I've got my tidy data table with where every column is a variable. So body dimension variable with 2 categories, height and wingspan. So I'm going to call these categorical. And then over here, these are my numeric data again. And I'm going to go right to graph. And so I want to show the categories, and I want to show the measurements. And what I want to create is what's called a stacked dot plot. And so body dimension is going to be my X variable, and measurement is going to be my Y variable. And so now you see this is called a stacked dot plot with random jitter. And so notice here it says set the jitter. And so it just randomly places a little bit of left and right jitter on the data points so that you can see them all. And there's no actual left-right value. So the distance to the left or to the right is meaningless. It just spreads them out so that we can see them. And if you don't like the way the jitter looks, you can always just kind of play around with it until you say, well, okay, I like that. That looks pretty good.
You can obsess about the random jitter for quite a while.
You can. And then again, I go right to appearance, and this is just how I like my data to look. So I'm going to drop the point size down to 7 again. And I'm going to close that. And then I want descriptive statistics here. And so notice that you have some choices here in descriptive statistics. And right now, it's just looking at the means, and it's giving us error bars that are standard deviation. And so I want standard error of the mean error bars, because those are easier for me to interpret. And then I also I like looking at the median and the range and the interquartile range. And so I like box and whisker plots as well. So now we have tons of information about the data. We can see the data themselves. We can see the means. We can see the uncertainty of the means with the standard error of the mean bars here. And then here's the median, the middle measurement. Here is the top of the bottom 3/4 of the data. So 3/4 of the data are below this line, and 3/4 of the data are above this line. And so this is called the interquartile range. And then the whiskers are the full range of the data here.
And you can note if people want to be reminded of that, the fine print below the graph, it shows exactly what the box and whiskers and the error bars are representing.
Right. And
Bob,
so
I have a question before we leave this graph.
Yeah.
You mentioned some of your preferences with regard to customizing the graph and the different descriptive statistics. Have you found that your students have any preference for either a type of descriptive statistic or how to represent the data in a certain way?
Well, I really focus on standard error of the mean error bars because they're just more useful visually. For example, if you can fit a standard error of the mean between the top of one bar and the bottom of the other one, then it's likely it's a statistically significant difference. 95% confidence intervals can overlap and you still can have a significant difference. So visually, I like standard error of the mean error bars, just because they give you more information, I think. And the box and whisker plots give you even more information. So I encourage my students to provide all of these descriptive statistics on their figures, just to give the reader as much information about the data as possible, to make the data completely clear. Nothing is hiding behind any curtains. With classic bar graphs, all you would have is just a single bar which is kind of all it does is just physically raise the mean up to where the top of the bar is, and you might have some error bars, but then you have no idea what's going on with the individual data points. And there's some really interesting stories sometimes going on in the individual measurements. And so you might see some clumping. We see a clump of 3 here. There might be something meaningful there. So we can go back and we can figure out, well, who's row 29, whose data are those row 29 and 190 or sorry, row 29 and who's row 35 and who's row 44. Maybe those are some interesting people, interesting students. So then of course, you can copy and paste this graph. I have my students actually turn off the notes once they understand what the data and statistics mean in their graph, and that gets rid of them, so that when they do copy and paste their graph to a document, it's nice and clean like this. Mm-hmm. So that's how I introduce DataClassroom to my anatomy and physiology students. Just very quickly, I also in my AP/IB biology class, we do a very similar thing with exercise and heart rate. And so here's a similar looking spreadsheet with student names, their resting heart rate. Then we all do jumping jacks for 1 minute, and we record our heart rate after that. We have a very similar looking tidy data table so that we can look at differences between the means. And then I walk them through the exact same steps that I did my anatomy and physiology students. And there you have it. That's my introduction to DataClassroom for my students in my classes.
Paul, where do you find that students have difficulty both conceptually with looking at data like these, but also just working with DataClassroom? What are the things that are places where they tend to get tripped up when they're doing it for the first time?
Well, where they get tripped up is they'll create a spreadsheet like you see here, and then they'll have all of these data tables on one spreadsheet. They'll have a data table here. They might have another data table over here of some additional data, and so on and so forth. And so they just create clutter on one spreadsheet. They don't realize that it's much more effective if they just use one spreadsheet per data set instead of a whole bunch of different types of data on a spreadsheet. So that's something that they have really never been trained to do in their classes. And another thing is entering data cleanly like this. And so students might enter 124 BPM here and 159 BPM or something, and they don't realize that they can just put that information in the column heading and just have nothing but numeric data.
Yeah.
So there's some things that they need to get weaned away from when they're using spreadsheets.
Yeah, I agree. And I always, when I'm explaining it to to people at really at a variety of different levels. I say the sort of overarching principle in working with data formatting and just sort of making it click is that you have to realize you're trying to think like a computer, because a computer is going to be thinking in terms of variables. And it's asking questions of, what variable would you like me to put on X? What would you like me to put on Y? What would you like me to color code by? And so you'd have to therefore have your data organized in variables the way that a computer thinks to make it work. I think we're still in this era where learning to work with data in a digital environment is still relatively new for most kids by the time they get to high school. I think, maybe 5-10 years down the road, that won't be the case, but I think that right now it is as far as what I see and talking to people in different places around the country and even around the world. Okay, I want to show one more data set. And Paul, if you have any questions about this as we go, or any points you'd like to make, feel free to just jump in there. But this, I'm gonna share my screen with you again, and this is continuing with our big problems theme. And this is one that looks at some global health, the role that economics play in healthcare and child mortality. This is not in the resource library yet, but if you want to follow along, you can go to the Browse tab and you can click data sets. And if you search this, if you search spending, the word spending, I think this will be the only data set that you'll find, unless you have some data sets with spending in the title. Those will show up as well. But it's, how does spending on healthcare affect child mortality rates? And there is a full lesson plan that goes along with it. We have just a little bit more than 15 minutes left of our hour. So I'll go through this relatively quickly, but just know that this is here and you can go and see it. There is the assignment is there. If you want an answer key to this, just drop us a line. You can email me or Blake. It's Aaron@dataclassroom.com or Blake@dataclassroom.com, and we'll send you the answer key. We don't put those up publicly anymore because teachers told us that kids find them very, very quickly if they're publicly available, and they didn't like that. So we now just have you request them. But this data set has 4 variables. It has this variable of country, which we've coded as info, which means you're not going to be able to do anything plotting wise with it. And there's 190 countries worth of data here. You can see there's child mortality rate, there's healthcare expenditure, and then there's population size for that country. And I'm going to show you the assignment here. At the top, you can see the table tab, the graph tab, and the assignment tab. This is relatively new for us. So if you've been using Data Classroom for a while, you might not have noticed this, this addition. I think we really only have sent out one email about it and maybe a couple of social media posts. But it is, the ability here is that you can embed any Google Doc or Google Slide or PDF from Google Drive, and you can embed it here. You can call it assignment, you can call it questions, answer key. You can embed I think up to 5 attachments to any data set. But here I've put in this assignment. There's a little bit of background information for your students. There's a link to the source where the data came from. It came from the Our World in Data website. And it explains that all these data were collected in the year 2014. And it gives you the definitions of the variables, sort of technically what went into those different measurements. And then you can see these 5 activity questions. And I'll jump over to the graphing tab and we'll kind of work through these. But the activity questions here are asking students to explore the relationship between healthcare spending and child mortality rate, to do a little bit of modeling with a linear regression and an exponential regression to see which model is a better fit for these data, and then talk about the implications of these data, as well as look at a very interesting outlier on the data set. So from here, I'm going to go to the graphing tab. And I've actually got this up. I'm going to clear this off and start from scratch. That was my mistake leaving that up there. But the first activity question asks you to look at this relationship between child mortality rate, and we'll put that on Y, and healthcare expenditure on a per capita basis, and I'll put that on X. And you get this plot with a really interesting pattern in the data here, where you have a whole bunch of countries with healthcare expenditures that are really clumped relatively close to zero. So these are low income countries that are spending very, very little on healthcare on a per capita basis, extending out all the way toward the right in countries that are spending quite a bit per capita on healthcare. And one of the things you're going to do here is in helping explore this pattern, you're going to add regression lines in the activity. And again, sorry, I forgot to reset this, but the default will first show you a linear regression like this, which there is an overall trend where as health expenditure goes up, as you move to the right on the plot, child mortality rates go down. However, I don't think the linear regression illustrates this pattern very well, or this model is not a great fit for these data. And so in this activity, students will first look at what a linear fit looks like, but then they'll also fit this exponential model. And you can see the equation for this model over here, but this is a much better fit for these data. And in a sense, the orange line, the regression line, is predicting the value of child mortality, or it's predicting the child mortality rate based on the per capita health expenditure. And so we'd ask kids to describe this pattern. And I think if you have, sort of at the most basic level, you'll get an answer like, oh, the more you spend on healthcare, the lower the child mortality rate. And that's not necessarily incorrect, but a more sophisticated answer is that you see this pattern of diminishing returns, or you see what, this curve that is present with this exponential model, where when you start spending money on healthcare, you see child mortality rates fall pretty rapidly, but then you reach this point of diminishing returns, where the more you spend on healthcare, you don't really see any more reduction in child mortality rate, and that never reaches zero for any of and no country in this data set has a child mortality rate of zero. And then the interesting thing is to start thinking about what are the reasons for this. And there's a whole host of reasons, and they're not necessarily going to learn about all of them in this activity, but this is more a platform to have a rich discussion about this stuff. And I could see this kind of data set being used in a science class, where you want them to work with some kind of data set and plotting scatter plot kind of data. But I could also see a very rich discussion of this in some kind of social studies class, where the purpose of the class is to study global issues like global healthcare, global poverty, and how economics relate to healthcare and those kinds of things. And there's definitely a lot to be discussed here. Yeah, any comments, Paul or Blake?
Yeah, I was just thinking how, though it's often not a focus of data analysis, this graph in particular kind of invites investigating some of the outliers. And it's cool how with DataClassroom you can pretty easily find and isolate those outliers here.
Yeah, one of the fifth activity question in this activity actually asks you to look for the country with the largest health expenditure per capita, which is this point over here, and then go to the table and see what country it is. Any guesses what it is? Or you already know, Blake. Paul, you got a guess as to who it is?
Boy,
Not to put you on the spot.
Singapore.
It is not. It is actually the United States.
Oh, okay.
we have our healthcare is very expensive in the United States. So it's the biggest healthcare expenditure per capita, but notably not the lowest infant mortality rate. You can see the infant mortality rate is 0.69 per 1,000 births, or child mortality rate, because I think it's mortality rate under 5 years old. But you can see, down here, the next closest in expenditure, the child mortality rate is 0.36. It's about half, roughly half of the rate there. And so there's a variety of things to think about. And I think it's interesting to think about countries on the high end of the spectrum in terms of what can be contributing to these differences in healthcare expenditure. And then I think it's also really interesting to think about countries on the low end of the healthcare expenditure and thinking about what's causing this steep slope in the early part of the graph, where spending just a little bit more on healthcare expenditure is correlated with dramatically lower child mortality rates. And I suspect it has much to do with that. Some of the most effective interventions in a healthcare system are also some of the cheaper ones. Things like basic sanitation in a hospital, things that have a dramatic effect on child mortality are not necessarily the most expensive. And then I think the other thing is that if you are a country, spending less than $100 per capita on healthcare, there's probably a whole host of other health issues that are present in that country, not directly related to healthcare expenditure, but just things that can increase the child mortality rate as well. So there's probably some variables at work here that are healthcare expenditure is not the only variable, certainly with some explanatory power on the child mortality rate.
Aaron, I've got a question. As you hover over the data points, you're given some information, but is it possible for DataClassroom to actually show the info?
It's a great question, and it is in the works right now. We have an engineering ticket written up, and so it's gonna come pretty quickly. And it's exactly, we first added this. This has only been added for, I want to say, about 4 or 5 weeks, where you can hover on a data point. And pretty quickly we realized that, it might be interesting to see a lot of those other things. And so what is probably going to happen, although this isn't finalized yet, the pop-up is probably going to be much larger, and it's going to actually show you values for all the other variables in the data set. So not only country, but it would also show you population. We will probably have to limit it though, because if you have, say, 50 columns of data, the pop-up will be unwieldy. So we might have to limit it to like 5 or something like that.
And you can get to a lesser extent with this one if you want to show the population as a Z variable, although you probably have to exclude.
Yeah, you could do, and this is gonna make a crazy rainbow of a graph. But if I had population here, and then I add it as a Z, population's a numeric variable, so it doesn't make the rainbow. But if I did country as a categorical, but we can't do it in this case because it's info. But you can get another piece of data color coded, and you can see population. In this case, you've got one country with a very large population, and that is actually, if we look at this data point, this is row 190. I suspect this is the world, the average for the whole world, and so it's got the big population on there.
And if we exclude that one, the color range is a little bit easier to interpret.
Okay.
Just a cool feature.
Yeah. So what was that row? I'll just show how to do this too. So this is row 190. So if I go back to the table, and I'm going to exclude row 190, and I exclude that, and I go back to the graph, it's marginally easier to interpret, but you still have big disparities. What you probably want to do, if you want that to be meaningful here, is you might want to log transform that variable, and so that you don't have such a huge disparity in population.
And Quentin, to your question about identifying the outliers, in any kind of any easier way than just scrolling through the data. We don't have that yet. You just saw, so kind of having to scroll through it in order to find those outliers, but working on that, as Aaron mentioned.
I see a couple of Q&A questions. Have we taken those yet?
That was, so just address Quinn's question. And actually, the other question from Imani would just have to do with Paul's willingness to share his lesson plans on anatomy and physiology, which we can follow up with after this is over, but I'll share that information with everyone.
Okay. Yeah, we will put together a follow-up page for this where we will have the recording hosted there. It'll also be on our YouTube channel, but you'll be able to get the recording, and then we'll have links to all the data sets that we showed you today in the course of this hour. We only have a few minutes left. Are there any questions that we haven't covered yet? Stop my screen share there. Okay, well, I think we've just about covered it. Paul, I'm so glad that your schedule and our schedule finally worked out to have you come and do one of these with us.
Yeah, this was fun. Yeah,
Right,
thanks.
yeah.
Thanks for all the participants for showing up.
Yeah, you got a lot of people putting some enthusiastic thank yous in the chat, so that they appreciate you as well, Paul. Yeah. Okay, well, with that, I'm gonna say goodbye and stop the recording. I can hang out a little bit if anyone has any follow-up questions. So thanks for coming. We've got one other thing I want to say. We have a special offer going right now. So if you are interested in giving DataClassroom a try but are not yet a customer, we have semester pilots running for $150 right now. And we also have school level pilots too. So if you're an administrator and you want to talk about that, Blake just put that in the chat. That is the link to the special offer page, and we'd love to help you get started. So with that, I'm gonna sign off, and thanks for coming.